So right now we want to evaluate this definite integral. So if we take a look at this, we immediately see that we should do this by integration by parts because there's no valid substitutions that we can easily make. If we try to substitute t squared, well, we still have this t inside. That's not going to be able to be substituted for anything. If we substitute this thing that's inside, we have the t cubed that's outside, which isn't going to be very useful for helping us solve this definite integral. So we have the product of these two functions, so we must use integration by parts. Now, to determine whether or not we should use, or we should differentiate the t cubed or the ln 5t, well, if we integrate ln 5t, we're going to get something that is more complicated. So if we take the derivative of ln 5t, then we're going to get something like 1 over 5t times 5 or something like that. And then so the 1 over t is going to be able to cancel out with the t cubed, hopefully. So let's give that a try. So we're going to differentiate ln 5t. So du is going to be equal to 1 over 5t, and then chain rule times 5 dt, and we're going to integrate t cubed. So dv is going to be equal to t cubed dt, and then v is going to be equal to 1 over 4 t to the fourth. So right now, all we have to do is find out what the antiderivative is, because the fundamental theorem of calculus tells us that once we know the antiderivative, all we have to do is plug in these upper and lower bounds of integration to find the definite integral. So right now, let's not worry about these bounds. We're just going to worry about finding the antiderivative. So from integration by parts, we know that if we have an integral in the form of u dv, this is going to be equal to uv minus the integral of v du. So from this, we can simplify or rewrite our integral as 1 over 4 t to the fourth times, no, there's no integral here. So I'm going to get rid of that. So we can rewrite the indefinite integral as this. So we have uv, which is ln 5t times 1 over 4 t to the fourth, minus the integral of v du. So that's just going to be 1 over 4 t to the fourth times, so these 5's cancel out, it's just 1 over t dt. So now we can see that our integral has simplified quite a lot, because this can cancel out very nicely. So we have 1 over 4t to the fourth ln 5t minus a quarter, and this can just be t cubed. So immediately we have our indefinite integral, which is this. And we can integrate t cubed very easily. That is just 1 over 4th t to the fourth. And so our indefinite integral will have integration constant. But what we are worried about is the definite integral. So to solve the definite integral, all we have to do is plug in our numbers 8 and 3, and the plus c's will cancel out when we subtract them from one another. So this is going to be equal to 1 over 4. So this term can stay on the outside if we distribute it through. So t to the fourth, that term will also be able to stay on the outside if we distribute it through. So we can just rewrite this as 1 over 4 t to the fourth ln of 5t minus 1 over 4. There's no longer a t to the fourth there because we distributed it. And we evaluate this at 8 and 3. Notice how the inside thing here that we're evaluating is the exact same as this. I'm just simplifying it. So what we have now is 1 over 4, 8 to the fourth, times ln of 40 minus 1 over fourth, and this is going to be subtracted, or it's going to be subtracting 1 over fourth, 3 to the fourth, ln 15 minus 1 over 4. Now if we simplify this, then we should get our answer.